Okay, so today's lesson is the ambiguous case, and it deals with if you have angle, side, side, you can be in trouble because angle, side, side is not the right word to use. We'll call it side, side, angle, and we'll just leave it there. Don't read backwards, okay? So, what happens is when you draw to scale 30 degrees, right? Here's my 30-degree angle. Measure this to be 10. This is for Julia, you guys. I get 10 there. And when I try and draw in 10 degrees, or 10 centimeters, when I try and draw side A, if that's angle A, side A is directly opposite. When I try and draw it in, it doesn't fit, which means there's really, in this case, no triangle. It's the ambiguous case. So it's possible to have all the information and not have a triangle. So it doesn't work, okay? Example 2, though, if we draw things to scale, do my 30-degree angle, there it is, my 30-degree angle, right? And here's B, I use my ruler and do that 10, there's my 10. And then when I want little a of 11, little a is opposite of angle A, so it stretches way out here to 11. And so this triangle does exist. So, okay, let's find out what we can find. So angle B, we can find B by sine of B over 10 equals sine of 30 over 11, and we cross multiplied, we solved, we used the inverse button, we got 27 degrees. Okay, now let's keep moving on. Angle C is easy, you guys agree? 180, right? To find angle C, so the measure of angle C is simply equal to 180 minus the 30 and the 27, right? That's easy. Okay, we can do that. 180 minus the parentheses 30 plus 27, and we get an answer of about 123 degrees for angle C. And then finally we've got to find little c, okay, angle C. And by the way, there is no Pythagorean's theorem. Pythagorean's theorem does not work. It's not a right triangle. Don't try Pythagorean's theorem, it won't work. But we can use the law of sines because we still have opposites, right? We have opposites, so we'll go. And Elijah, I always like to write down what I want to find first. Does that make sense? I want to find C. So go C over the sine of 123 equals, you ready? 11 over the sine of 30, right?
The opposite thing?
Yeah, the opposite thing. 11 over the sine of 30. And then we'll cross multiply, okay? So we'll go 11 sine 123 divided by sine 30, and we get about 18.45. Not too bad? Not too bad? Everybody okay with this?
Yes.
Okay, now, when you're ready, we'll turn the page. We're going to see that darn double triangle, okay? And we're going to solve for both, but I'll show you how it works, okay? Madeline, if I get going too fast, tell me to slow down, okay?
Oh, no.
All right, you okay? All right, turn the page, you guys. Everybody good? All right, here we go. So let's try and draw this one again. So angle A, again, the way I like to draw it, I'll just put a dot here and call it A, okay? And I'll scooch it over, okay? I just like to, this is called the terminal side. Just draw it as long as I want. I don't know how long it is, but I am going to put in my angle A, so I use my protractor, put the little dash on angle A, zero it out, right? Zero it out. Let's find 30 degrees is right there. Make a little dash mark at 30, right? And I want to draw this one 10 centimeters, so I use my ruler. Let's draw it out 10, okay? 10's right there, okay? Okay, there's my 30 degrees. That's B, which is 10, okay? Now, I want to draw in 6. So there are two ways. In this case, you guys, we already looked at it already, but let's see it again. So you could draw the 6 here. Everybody watching?
Yes.
You draw the 6 here, but you might have drawn the 6 there. Both triangles are the same, okay? They both work. Well, they're not the same, but they both follow the same directions, right? So they're both correct. Here is one of them. Let's draw this one first. Okay. And let's solve the big triangle first, and we'll come back to the small obtuse triangle. So first of all, let's try the big triangle. So let's go big triangle. We'll solve over here, okay? So I do know...
Your other side.
Yeah, I do. So this is 6, which means if this is B, this is angle B, right? Which would force this to be angle C, right? So I have my opposites, right? So I could find angle B because of opposites, right? So I'll set right off the bat. I'll take my sine of B over 10, right? Sine of the angle over its opposite side equals the sine of 30 over 6, okay? Multiply that up, right? And if I do that, I'll have 10 times the sine of 30 divided by 10. And I get a decimal because I need to find the angle. What button do I push?
Angle.
The inverse button, right? So we'll go sine inverse of my 0.5. And of course, we already know that answer. So B, like 30, well, hold on. B over 10 equals sine of
I
30
got
over 6.
something that different than the 0.5.
I did 2. Hold on. 10, that's because I divided wrong. Sine of 30, 10, clear. 10, I did get some.
You
Sine
should get the decimal of 8.33.
of 6. Yeah, 0.833. Thanks, Marie. Sine inverse that, right? So I'm going to go sine inverse of that answer, about 56.44, okay? There we go, that's better. Angle B. Everybody good on that? And then angle C, right? To find angle C, we'll just add them up, subtract from 180. So there's angle B, which is equal to about a 56.44. And then to find angle C, 180 minus my 30 plus my 56.44. How am I doing? Am I okay? Right? So, alright, I can do that. 180 minus parentheses 30 plus 56.44, and I get an answer about 93.56. So angle C is about 93.56. Okay, let me put that in there, 93.56. And then we can find little c, can't we? Am I going too fast? Okay, I'll wait for a second, okay? So when you're ready, we'll do c by the opposites again. Little c over the sine of that. We'll do our opposites. Opposite, 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 okay? So we'll set up little c over the sine of its opposite angle, which is a 93.56, equals the 6 over the sine of 10, right? Okay, multiply up by 6, and it goes 6 times the sine of 93.56. Close my parentheses, divided by sine of 30. Okay, there it is on my calculator. Enter, and I get an answer about 11.97. Okay, so little c is about 11.97. Okay, not too bad, right? We agree? We agree. Now, to find the other triangle, let's redraw it. Let's draw it again. So let's say that we happen to be drawing it totally differently. Okay, so here's the triangle I'm going to draw. Okay, I want to draw this one. Do it in a different color. Okay, I'm going to draw this triangle, but this time I draw the 6 right there. Okay, so if I get the 6 right there, you guys see it? So I draw this triangle instead, right? You guys see there the triangle? So I draw that triangle instead, which that triangle is correct. It's just a different size, right? So my 6 is still here, but this triangle is not there anymore. Okay, this part of it's not there anymore, right? Great, but we're going to use this triangle to help us out. So if the first thing I want you to notice is this. Everybody watching? Everybody. Here's the key. You will miss this if you're not watching. This is what everybody gets to this step on the quiz and they don't know what to do. Okay, but you're not. You're going to see it, right? 6 and 6. What kind of triangle is this? 6 and 6.
Isosceles.
It's isosceles. What do you know about these two angles?
They're the same.
They're the same. They're totally the same. Because if you do all of this work without thinking this, you will get a 56-degree angle. But that's not 56, is it?
No.
Not at all. Your calculator will give you an answer 56. this angle's not 56, but this angle is 56.
Wait, so what if you just have that triangle and you had to find it? Would you have to do that whole thing too?
You would have to do that whole thing, or we need the law of cosines. Now, great question. Here's what we know. So let's go back to this stupid unit circle. You guys know this, right? Here's what you know. When you find the sine inverse, you either get the answers here or here, don't you? Right? Remember that? Sine inverse, because it's the y, right? You get the answer here or here. You never get an answer here. You'll never get 120 degrees on your calculator for sine. Never. So how do you do it? With cosine, but we'll learn that tomorrow. Now, what we're going to have to do is realize the fact that we're going to have to recognize that's an isosceles triangle. These two sides are equal, which makes those two angles. So then to get this angle here is pretty easy, right? We're just going to go 180 minus my 56.44, right? Straight line makes 180 degrees. 180 minus my 56.44, and I get this angle now to be 123.56, okay? So in this case, angle B is found by going 180 minus my 56.44, which turned out to be 123.56, okay? There's angle B, all right? So angle B is here now. How am I doing? Okay. Now, again, it's a totally different triangle, right? So that means angle C is going to be a different angle also, right? So to find angle C, well, that's easy. 180 minus my 123.56 plus my 30. So add these two. Add these two and subtract from 180, right? So 180 minus my 123.56 plus my 30. And I get an answer about 26.44. So this angle up here, angle C, is 26.44 degrees. Okay, so that's 26.44 degrees, right? Okay, now we need little c, which is no longer all of this, but this little part here, right? Little c is no longer all of this because this part's gone. We just need those part here. So again, opposites. Opposite, go little c over the sine of 26.44 equals 6 over the sine of 30. We'll multiply that up, right? And we'll go 6 times the sine of 26.44 divided by sine of 30, and we get an answer of about 5.34. Okay. 1, 2, 3, 4 problems. That's it. But you got to draw them to scale. You can do it, right? That's it. Should be easy, right?
Perfect.